Hey guys, so today what I want to talk to you about is GCF and LCM word problem keywords, okay? And I got a little chart here for you. Let's go ahead and title this. This is, oops, I was in my wrong pen. I'll change that. This is lesson 1-1 still, GCF and LCM word problems. So yesterday, we talked about how to find GCF and LCM. We talked about two different strategies. We talked about using prime factorization or the factor ladder. I'll be honest with you, I'm going to be using the factor ladder. You can use either of the methods, whichever you feel most comfortable with. But the key thing is we got to be able to recognize words that mean greatest common factor and words that are going to tell us we're going to look for the least common multiple. So what we have here is a Venn diagram, and you can notice that there are 4 words in the center that are the same for both of them, and those are the words that stand for common: identical, same, similar, common. So in other words, those words are not going to help us figure out if this is a GCF or an LCM word problem. Okay, so let's look on the left side, because the words on the left side, these are the words that do mean probably this is going to be finding the greatest common factor. So words like greatest, largest, biggest, divide, arrangement, break, and what break means is kind of like break into smaller pieces or smaller groups. Most, split into smaller pieces, arrange something into rows or groups. So notice probably the most interesting word is the word most. At most, that means it's got to be the greatest, okay? So those are all words that when I read them in my word problem, they're going to tell me you're looking for the greatest common factor. So what are the words that mean the least common multiple? And they would be the words on this side. Words like smallest, time, least, buy or get multiple things, find something that happens at the same time, find an event that repeats over and over. So that idea of repeating. And I'm going to add one more that we had seen as well, and you might see something like every and then so many days, every so many hours. Okay, something along those lines. Okay, so let's go ahead. We're going to do 2 separate problems. Now, I gave you the page. You're going to cut out the problems and you're going to glue them in. And we should be able to get both of them on one page. So, and maybe you'll get one on this page and one on the next page. So I'm going to go to my second page. So here's our first problem. Mary and Nancy worked at a calculator producing factory. All right, that's interesting. It is their job to inspect the calculators to make sure they are working before the calculators are shipped to the stores. If Mary inspects every 12th calculator and Nancy inspects every 9th calculator, which calculator will be the first that they both inspect? So this is the thing that kind of triggers in my brain. Every 12th calculator, every 9th calculator. So I'm going to go back to that chart on the other page. Where did I hear something? Oh, that's what I wrote down at the bottom. Every so many days, every so many hours, every so many calculators. Seems to me that what we have here is an LCM problem. Okay? So they want to know when they both are going to inspect the same calculator. Okay? So 2 clues that help me decide were the every 12th calculator, every 9th calculator. So those were kind of my helpers. And another word that kind of stood out to me was this one right here, first. What's the first time that they are going to have this value in common? So I'm going to write that as well as being a key. So since I'm going to do LCM, I'm going to take my two numbers, which are the 9 and 12, and I'm going to use the factor ladder. So let's see, these two have a 3 in common, and that's going to give me 9 divided by 3 is 3, 12 divided by 3 is 4. Now, that's can't really divide out anything else, so what I'm going to do is circle up all the outside numbers from my ladder, and then I'm going to end up multiplying them together. So I get LCM is going to equal 3 times 3 times 4. So I get 9 times 4 is 36. So what this is saying is the first calculator Nancy and Mary will, the first calculator, Nancy and Mary will inspect will be the 36th calculator. Okay? So again, those words were telling me I needed to find the least common multiple. So I can't look at pieces of it. I can't look at the factor. It's like 12, 24, 36, and so on calculators, 9, 18, 27, 36 calculators, and 36 is our magic number. All right, let's try another one. There are 100 seniors and 80 juniors in the homecoming parade. Oh, that's interesting. The students split up into groups of equal size. Ooh, that sounds familiar. Split up groups equal size to fit on the parade floats. They want the most students possible on each float, with just juniors or just seniors on each float. How many students should be on each float? All right, I'm going back to that first one. Let's see. We're talking about arranging something into rows or groups. Most. Okay. I think there was was it split? What was the other word? Split up into equal groups. For sure, this is GCF, without a doubt. So let me write down those words. We had split up groups of equal size. We had most. Okay, so all of that says for sure that is a GCF. So let's get back to the matter at hand. Let's do our two numbers. Let's see, we have 100 seniors and we have 80 juniors. So again, I'm going to use the factor ladder. I just really like that method. And let's find something they both have in common. Well, they both end in a 0, so 10 will come out. And that's going to give me 100 divided by 10 is 10, and 80 divided by 10 is 8. I notice both numbers are even, so I'm going to divide. Ooh, I'm going to change that color. Go back. I'm going to divide out a 2, and that's going to give me 10 divided by 2 is 5, and 8 divided by 2 is 4. Now I can't pull anything out, so here's how the ladder changes when I'm trying to figure out GCF. I just look at what's on the left for GCF. So the GCF is going to be the product of 10 times 2. So the 5 and the 4 don't factor in this, and I get 20. Okay? So how many students should be on each float? What this says for my final answer, there should be 20 students per float. So in other words, I can break 100 into 20s, I can break 80 into 20s, and that is the greatest number of students that I can fit on each float, because 20 is the greatest number that can divide into both 100 and into 80. Okay? And that's how we do this problem. All right, we're going to do a lot of practice in class, so we'll talk about it tomorrow. Have a good night.